Welcome back. Today I'm going to be going over 5 multiple choice questions related to some indefinite integrals. So let's dive in. All right, so first one asks for the general solution to this problem here, the integral of 3x squared minus 4x plus 1. So what we want to do here is we basically want to find like the family or the collection of all the antiderivatives of 3x squared minus 4x plus 1. So first, I'm going to start with 3x squared. What's the antiderivative of 3x squared? Well, that would be x cubed. And we can verify that by saying, well, what if we took the derivative of x cubed? We would indeed get 3x squared. And so that confirms we did it correctly. Then as for 4x, that would be 2x squared, right? Because confirm that if we were to take the derivative of negative 2x squared, we would indeed get negative 4x. So we know we've done that correct. And then for 1, it would just be x, right? Because the derivative of x would be positive 1. And then because we want the general family, we have to put plus c, plus a constant. Now, why could there potentially be a constant? Recall that if there was a constant here, which there might be, there might not be, we're not really sure, but there could be some constant here, because if we took the derivative of a constant, it would just go to 0 anyway. So the constant could be anything, or we might not have one. It could just be plus 0 there, and that would work too. And so basically, this is the indefinite integral, which is the family of all possible antiderivatives for this function. And looks like this matches perfectly with A, and so that's what I'll be circling here. All right, so for this one, the only difference looks like we are dividing by x. Luckily, though, we can actually cancel out an x from both of the terms in the numerator to simplify this. So I'm going to simplify this to the derivative of x squared plus 2. Then to take, I said the derivative, I meant the integral, the indefinite integral. So what's the integral, the indefinite integral, or the antiderivative, I should say, of x squared? Well, that would be x cubed over 3. And then what's the antiderivative of 2? Well, that'd be 2x. And then because we want the family of all the antiderivatives that are possible, we're going to do plus c, because there could be some constant here that was differentiated into nothing, since the derivative of all constants is nothing. And so my answer is answer A. All right, so this one says, which is the result of the integral of e to the power 2x plus sine x dx? Okay, so to figure this one out, same thing as before, we have to take the antiderivative of each of these and then add plus c in order to account for all possible antiderivatives of the function overall. Okay, so first of all, what's the antiderivative of e to the power 2x? That would be 1/2 times e to the power of 2x. Because recall that if we take the derivative of e to the power 2x, what do we get? We get e to the power of 2x times 2. So we have to have the 1/2 here to combat that, so that when we take the derivative of this, we get this. Okay, and then what's the antiderivative of sine x? Well, that would be negative cosine of x. And then, of course, we add plus c because we want to account for all possible antiderivatives in the entire family. And so my answer would be this first one right here. All right, so here's another one. It asks, what is the integral of secant x times secant x plus tan x dx? Okay, so for this one, it might be hard to know because we don't really know what the integral of this is exactly just by looking at it this way. However, something that I notice here is that if I use the distributive property to distribute secant x with secant x and secant x with tan x, that's going to make the problem a lot easier because a lot of these would be derivatives that we do know, which is good. So let's expand it first. So we're going to get that the integral of is going to be of secant squared x plus secant x tan x. So that's our first step. Then I'm going to take the antiderivative of secant squared x. So recall that the derivative of tan x is equal to secant squared x. And so therefore the antiderivative of secant squared x would be tan x. So I'll be writing tan x on the next line. Also recall that the derivative of secant x is equal to secant x times tan x. And so therefore the antiderivative of secant x tan x would just be secant x. So this would turn into plus secant x. And then, of course, we want to have the family of all of them, so we're going to add c there as well. And so the answer is A. All right, now I'm going to do one last one for this video. I will also have other videos on like integration by parts and more complex ways to find the integral, fundamental theorem of calculus, all that good stuff. For now, let's work on this one though. For this one, we're actually going to use u substitution. So what I'm going to do is I'm going to let u equal ln x for this one. And then what I'm going to do is find the derivative. So the thing is, du over dx must be equal to 1 over x, right? Because what's the derivative of u with respect to x? What's the derivative of ln x? It's 1 over x. So that's how I got that. Then I'm going to multiply, or I guess kind of apply dx to both sides. So we're going to get that du is equal to 1 over x dx. And then from there, what we can do is we can actually do the substitution. We can then say, well, we want to find the derivative of 1 over x ln x dx. So that's the same as the derivative of 1 over u du. Because du is just 1 over x dx, right, which we had. We had 1 over x, let me circle it, 1 over x dx, and so this part became du, right, because du is equal to that over here. And then ln x turned into u because u is equal to ln x over here. So I just want to make sure it's clear how I went from this step here to this step here. Okay, and now with that out of the way, let's actually take this integral. So if I take the integral, I'm going to get ln u plus c. And then I'm going to replace u with, we remember u is equal to ln x, so I'm just going to replace that back. And so this is ln of ln x plus c. And so therefore the answer is the first one, which is answer A. All right, well, as always, if you do have any questions, feel free to leave those in the comment section, and we'll see you for the next one.